So in this video, I'm going to explain to you how we teach Year 2 children to subtract a 2-digit number from a 2-digit number where exchanging or regrouping is required. So for example, 63 minus 17. Now, as with most things, we will get children to use the resources first to help them understand how to do this. And as I mentioned earlier, if you haven't got tens and ones, then you can make use with your bundles of spaghetti or your matchstick bundles to make 63. So as you can see, I've made 63 with my 6 tens and my 3 ones. The next step is to partition that second number into tens and ones. So I know that 17 is made up of 10 and 7. So the first step is to subtract the 10, and we can do that pretty easily because we can just take away a 10, and if children know that 6 take away 1 is equal to 5, then they're going to be able to use that related fact of 60 take away 10 as being equal to 50. So that will help them know that 63 subtract 10 is going to be 53. They have to have 5 tens. Now, they've subtracted the 10. Now we need to subtract the ones. And you can see that we don't actually have enough ones to subtract 7 from. Children are really familiar with the idea that 1 10 is equal to 10 ones. So in this situation, we've taught children that they can exchange 1 10 for 10 ones. And when they do that, when they decompose and break down a 10 into 10 ones, they can now subtract 7 a lot more easily. So some of them might use their number bonds to know that 3 and 4 make 7. So they can subtract these two numbers, and then they might be able to see straight away that they've got 4 tens and 6 ones. And so they'll be able to tell that 63 subtract 17 is going to be 4 tens, 40, and 6 ones, 6. So this is a way that we would introduce children to subtraction with exchanging first. They would have to do it practically in order to be able to understand what needs to happen and to understand the nature of exchanging. Once they've had plenty of practice with doing this, and just before I move on, it might be key to mention here that if you're using bundles, instead of exchanging a 10 for 10 ones, all you'll have to do is actually unwrap the elastic band, and straight away you've got your 10 ones and it's already been broken down. So you won't need to exchange anything like we do with the tens and the ones. You'll just need to break apart a bundle of 10 so that you've got 10 ones. And as I say, it's really important that children get this practical practice so that they can understand what exchanging means and how they can solve these problems. Once they are really familiar with using the resources to help them to physically exchange, then they move on to a slightly more abstract method. So if we take the same equation again, this time children, if they don't need to use the resources, can just straight away partition the 17 into 10 and 7. Now it's really important that children just partition or split that second number. They don't split both numbers. They've been taught with addition that they can split both numbers to find the answer, but it's more efficient here if they just split that second number. So that's what I'm going to show you to do. Now, just as before, we can subtract the 10 and we'll get 53. And then we need to subtract the 7 ones. Now, children might be tempted to put 53 in their heads to get 7 fingers out and to count back. So for example, 52, 51, 50, 49, 48, 47, 46. Now that's a method that some children might use, but we've been encouraging children not to use that method. And the reason for that is that if children do rely on their fingers, one problem is that they can make avoidable mistakes when they're counting. So typically they might be just one number short of the answer if they miscount. So instead of that, we encourage children to use their known facts to help them. So, for example, we teach children how to split the 7 in a way that really helps them to solve this equation quickly and effectively. So we tell children that they need to get down to the previous 10. So they need to reach 50. And in order to get from 53 to 50, they need to subtract 3. So that first part needs to match the number of ones that's within that first number here in the equation. Children then need to use their knowledge of number bonds, so they should be able at this point to automatically know that if we've split 7 into 3, we've got to have 4 on the other side because 3 and 4 make 7. Then it's a case of subtracting. So now 53 subtract 3 is going to be 50. And then they need to subtract the 4 from the 50. To get 46. And so 63 subtract 17 is going to be equal to 46. Now, at this point, it's useful to refer to how we've taught children to solve these facts quickly. So if they want to solve 50 subtract 4, they should think about their subtraction facts to 10 to help them. So if they know that 10 subtract 4 is going to be 6, they should use that fact to work out that 50 subtract 4 is going to be 46. So these related facts might take a bit of practice, and it might be that your child isn't particularly fluent with these sorts of facts yet. So this is something that you can help your children to do to achieve that fluency, to practice. So for example, if I know that 10 subtract 4 is 6, I also know that 90 subtract 4 is going to be 86, and 70 subtract 4 is going to be 66. So getting children to use those facts is really important so that they can solve these sorts of equations efficiently and quickly. So that's how we outline the more efficient written method for subtraction with exchanging. And children are likely to need a lot of practice to develop fluency in subtracting across a tens boundary in this way. So what you could do is provide lots of varied practice. So this might include missing number equations. So for example, 75 subtract something is equal to 60. So as before, you can get children to represent this, as we've discussed, in a bar model to help them. So they're going to know that 75 is the whole number. They're going to know that 60 is one part. So again, they're going to reason that in order to get this missing part, they're not going to add these two numbers, they're going to subtract them. So for example, 75 subtract 60, and then they would go through all the steps that I've shown you previously in order to find that answer. It's also important that you present missing number problems within bar models and part whole models. So for example, 42 having one part as 26, and then again a missing number here. Or you could write that or model that within a part whole model as well. Again, these are representations or drawings that children are quite familiar with. So you should get them to think about the relationship between these numbers to help them to solve the missing parts. So again, with the part whole model here, children can see that they've got the bigger whole number, they've got one of the parts, So to get that other part, they're going to have to subtract the 26 from the 42. The other thing that's really important to do is to provide children with word problems with real life contexts. So in the previous video on subtraction, I showed you an example, and you can use this kind of example, the same kind of example, but this time you can get children to subtract with exchanging or regrouping. So just fiddle the numbers slightly so that it requires exchanging. If you want to challenge your children further, this is an example of how you can do that. So I've got a word problem here. So Paul had 65 stickers. He gave 30 stickers to Mia and 16 stickers to Amy. How many stickers does Paul have left? So you can get your children to identify the numbers. So we've got 65 here. He gave 30 stickers to Mia and 16 stickers to Amy. How many stickers does he have left? So there are a few clues that children can get in order to help them to realise that this requires a subtraction equation. And here, the difference and challenge now is that we've got not just one number to subtract, but we've got two amounts to subtract. And so this provides further challenge for children and allows them to sort of deepen their understanding of subtraction with exchanging. So children may work this out in various ways. So we've got 65, we're subtracting 30, and then we're subtracting 16. So some of your children, after they've partitioned the 16, might actually combine the 30 and the 10 to make 40. And so they might just subtract the 40 instead of subtracting the 30 first and then the 10. So again, using that knowledge of subtracting, if they know that 6 subtract 4 is 2, they're going to know that 65 subtract 40 is going to be 25. And now they've just got to subtract the 6 ones. And again, if they split, they need to get down to 20. So they need to subtract the 5 first to get to 20. They know that 6 is made of 5 and 1. So if we subtract 5 from 25, we get 20. Then we subtract 1 more. We're going to get 19. So that's one way they might solve a problem like this. But there are several different ways that children might solve it. And as a challenge or an extension, if your child is capable of solving a problem like this, then you can ask them to tell you how they might solve it in a different way or using a different method to further extend them. And just go with what they're using, what method they're using. Get them to explain how they're working it out. It might be different to how you expect, but as long as children are able to explain the method, as long as they're able to work efficiently and fluently, then that's what's important, that's what's key. So I hope that you found this video useful. If you have any further questions about supporting your children with their fluency facts, then do get in touch with your class teachers.